Hello, it's Coach Fred here, and today I decided to go over question number 44B on page 26 of the summer work. So we're talking about systems of equations. This particular question asks you to use elimination to solve. And if you went back and looked at the original video on systems of equations, it really is important for you to recognize the three possible solutions you can have. Of a linear system of equations. You have two lines, right? We know that they're two lines, and they're either going to intersect, and if they intersect, you'll get one solution, which is that point of intersection. We can have no solution, which means that the lines are parallel, and we can have infinite solutions, which means they are the same line. Well, that's all well and good, except what happens to the equations when you're solving them? Like, how am I going to know it's this? Well, if you're solving and you're going to get one system, you're going to get an x or a y. You're going to solve it and you're going to get x equals. But let's pretend we had a system of equation that looked like this. 2x plus 3y equaled 7, and 2x plus 3y equaled 9. And you tried to use elimination, so you subtracted them. And what happens? You get 0 equals -2. Well, that right there is not a true equation or not a true statement. So that means there's no solution. And no solution as it relates to a system of equations means the lines are parallel. So you'd want to state that, okay? If it were the same line and you did that, and you solved it by using elimination, so you subtracted the equations and you would end up getting a true statement, 0 equals 0. That would tell me that all real numbers is the solution, which means all answers, which means that there's infinite solutions, so the same line, okay? So that might help as we look at number 44B. 44B, I look at it and said use elimination, so I would want to make one variable have the same coefficient but opposite signs. And I always go with the variable that it's the smaller numbers because it just makes the multiplication easier. So I'm going to multiply the top equation by 3 and the bottom of equation by -2 to make the x's the same coefficient that have opposite signs. All right, so that's going to give me 6x minus 30 equals 3. And the bottom's going to give me, let's see, -6x, 30y, plus 30y equals -8. All right, so if I took that next step and I subtracted, these are going to get eliminated. These are also going to get eliminated, which means they eliminate to 0. And over here I get -5. Okay, that looks funny. I know it's scary, but I want you to think, is it a true equation? It is not a true equation, okay? So it's no solution, which tells me that these lines are parallel. And just as a reminder from earlier questions, we know that parallel lines are lines that do not intersect, right? But they have the same slope. Okay, hopefully that was a helpful video. Have a great day.